All right, here we are again. Hey guys, I just wanted to make sure that we understand what the heck is going on with some complex numbers. So if you could just watch this video and at least try to get an understanding before you come to class again, I think it'll help you out. So I kind of started talking about how we're going to take something like I to the 21st and reduce it down and get an answer without having to do that pattern over and over again. Speaking of the pattern, I'm going to write it down on the side. We know that I to the first is just I. My pencil's a little too skinny. Let's try that again. I to the first is I. I squared is -1. I cubed is -I. And I to the fourth is 1. And I mentioned this in class, but I to the fourth being 1 is going to really help us out. Essentially what we want to do, guys, is figure out how many I to the fourths go into each number up here. So if it was like I to the 120th, we want to know how many I to the fourths go into that. I'm going to expand this the long way, because in class I kind of skipped, a couple levels there. And I should have kind of explained this a little bit better. So remember how, this is another side note, when we learned about exponents back in the day, we know like x squared times x cubed is x to the 5th. And that's because we have to add our exponents. Okay, same thing with I. So I to the 2nd times I would be I to the 3rd. So what we're going to do is we're going to take whatever number they give us, like this 21, and we're going to split it up. And we're going to split it up into as many I to the fourths as we can. So if I have I to the 4th times I to the 4th, that's I to the 8th, because I just add 4 plus 4. Let's add in another 4. That's 12. Here we go. We got another 4. That's 16. Oh boy, another 4. That's 20. Okay, now there's not another 4. So there's 20, but I still have 1 left over because I want 21. So this is the long way to do this. I have I to the 4th times 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 I. Well, guess what, guys? I to the 4th is 1. So we have 1 times 1 times 1 times 1 times 1 times I. Well, what's 1 times 1 times 1? That's all 1. 1 times I is just I. So that's your answer. Now, I don't know about you guys. That would kind of suck to have to write out I to the 4th that many times. So I have another strategy. The shortcut. Now, in class, I was writing it like, oh, you guys, we have I to the 4th, we have it 5 times. And then we have an I. That's what I just did here, because look, there's 5 I to the 4ths. However, I think that's hard for people to see, so I have a different shortcut that I want you guys to try. And here it is. If you take 21 and you divide it by 4, you can use a calculator or you can do this in your head, okay? 21 divided by 4 is 5 and 1/4, or 5 with a remainder of 1. The remainder is the degree of your I in your answer. I to the first is just I. So again, you take whatever this number is, 21, you divide it by 4. Okay? Whatever the remainder is, that's your degree. In your final answer. Let's try again with another example. All right, so let's try to use the shortcut here instead of writing I to the 4th out as many times as we can. So let's take 18 and divide it by 4. Okay, well, 18 divided by 4. We have 4, and then we're left over with 2. 4 and 2/4, 4 1/2, or 4 remainder 2. The remainder is going to be the degree of your answer. So you take an I and you write the remainder. Well, I squared is -1. So my answer to this one is -1. That's going to be quicker. And eventually what you're going to learn after doing a lot of these is that if you have an even exponent, or I raised to an even power, guys, even powers are either going to be divisible by 4 or divisible by only 2, if it's not divisible by 4. So if your even power is divisible by 4, then the answer is 1. If it's an even power but not divisible by 4, in other words, there's going to be a remainder, it's going to be I squared, which is -1. So your even power answers are either going to be 1 or -1. Let me repeat that. Your even powered answers. So anything I raised to an even power, your answer will either be 1 or it will be -1. If that power is divisible by 4, it's 1. If it's not divisible by 4, but it's even, the answer is -1. Let's go on. So I'm going to do the rest of your notes here. Those first two parts were part of your notes. So we got the answer to 1. We got the answer to 2. The next one. Okay, 88. It's even. So I check to see if it's divisible by 4. 88 divided by 4. Well, we get 22. So 88 is divisible by 4. Remember, if it's divisible by 4, then our answer is 1. Literally, that's just the answer. Long version. The longer way to do this, guys, is to write out our answer like this. When I divide 88 by 4, I have I to the 4th raised to the 22nd. I to the 4th is 1. 1 raised to the 22nd is 1. So that's the longer way to do it. Or we can remember, if it's even and divisible by 4, the answer is 1. Let's do our next problem. That was number 3. Okay, now number 4 is odd, so it's not even. We can't use our trick with the evens, but we can divide by 4 and figure out what the remainder is. That'll be our answer. So 203 divided by 4. Obviously, that's not going to work. You'll get a decimal if you put that in your calculator. All right, so then you might want to recognize, like, 4 definitely is going to go into 200. That's actually 50 3/4. Or you might see 50.75. So you should know that 0.75 is 3/4, which means your remainder is 3. Which means that your answer is going to be I to the 3rd. It's just I to the remainder. You just have to memorize that, hey, I to the 3rd is -I. So your answer here is -I. Moving on, another odd, so we can't do our evens trick, but we can divide by 4 and find the remainder. Take 87, divide it by 4. Let's see. 4 goes into, yep, it's going to be 21. 4 goes into 87 21 times with 3 left over, 3/4. That means my remainder is 3, which means my answer is I to the 3rd. Oops, which is -I. And almost there, guys. Number 6. This is even. So it's either divisible by 4 or not if it's even. So let's do 102 divided by 4. Well, that ends up being, what, 25.5. So it doesn't work. So it's not divisible by 4. So remember the evens trick. If it is divisible by 4, our answer is positive 1. And if it's not divisible by 4, then the answer is negative 1, or I squared. All right, so that should help us out. And now I'm going to talk about the last part of the notes that we were supposed to get to. Guys, this is just operations with complex numbers. Essentially combining like terms, FOIL, all that fun stuff. I'm just going to do a couple examples. We treat I like a variable. So here, 2I plus 5I is just 7I. That's it. 10I minus 2I is 8I. Just like combining like terms. What about here? Okay, well, combine like terms. I can combine my real numbers. 5 and 2 is 7. And I can combine my imaginaries. I minus 2I would be negative I. And that's your answer. Obviously, things can get more complicated, like in number 4. But just like in Algebra 1, guys, you distribute your negative. We have 3 minus I minus 5 minus 10I plus 3I, and combine all your like terms. My real numbers I can combine. 3 minus 5 is negative 2. And then I can combine negative I minus 10I, that's negative 11I, plus 3 is minus 8I. Remember to write your final answer in this form where it's A plus BI, so that your real part comes first and your imaginary part comes second. I'm not going to do the last example. We can do that in class. I just wanted you to get the gist. But I will do some of this because this is my favorite part. When we multiply complex numbers. Well, this is just distributing. You guys know how to do that. 3 times 5 will give me 15I. But here's the fun part. 3I times 2I. 3 times 2 is 6. And I times I is I squared. In Algebra 1, you would stop here. But hold up. We know something about I squared. I squared is negative 1. So I actually have 15I plus 6 times negative 1, which is 15I minus 6. And I'm going to write my final answer with my real part first. So the negative goes with the 6 plus 15I. Let me back that up and show you guys that again. Or at least something similar. Let's multiply 3 times 3 times negative 3, is negative 9. Now here's the fun part. I times I is I squared. But we know I squared is actually equal to negative 1. So now I just multiply negative 9 times negative 1, which is positive 9. What I'm doing is I'm taking the product of two imaginary numbers. It actually turns it to a real number. So last one. Multiply your real parts, right? 12 times 9 is 108. I times I is I squared. But I squared is negative 1. So I have 108 times negative 1, which is negative 108. All right, guys, I really hope this helps you a little bit. And we'll talk about the rest tomorrow. Bye.